One thing that regularly strikes me is that students are very confused about the electron volt. So the aim of this video is to attempt to bring some clarity to that area of confusion. The electron volt is simply just a measure of energy, and as you know, energy is always measured in joules, period. It just is. But you're used to this idea of actually having two different units for a quantity. So for example, take impulse. Impulse can be measured in kilogram meters per second, or also Newton seconds. A similar thing is going on here with the electron volt. You'll have noticed that electron volts crop up mostly in areas of particle physics. So we could, for example, talk about the energy of an alpha particle being 2000 electron volts. Or we could put that in joules and it would come out as 3.2 times 10 to the minus 16 joules. Now, which of those is easier to work with, do you think? This is one reason why we use electron volts. First of all, let's clear up another confusion. What's the difference between this symbol and this symbol? One of them is an E, one of them is an E minus. Now, I mean E minus, that is the symbol for an electron, or you could have the symbol for a positron as E plus. But E on its own, that is the symbol for the charge on the electron, 1.6 times 10 to the minus 19. Now notice that in our formulas for electron volts, we always have E without a minus or a plus, so in other words, the charge on the electron.
In order to define the electron volt, we're going to start off with a simple 1 volt cell connected to two parallel plates. You can see that the top one in this case is positive and the bottom is negative, and that these plates are separated by a distance d. This means that there will be a regular uniform electric field going downwards from the top plate to the bottom plate. Remember, it goes in the direction that a positive charge would move. We are now going to consider a single electron just about at the negative plate. This will feel a repulsive force away from the negative plate, and so it will accelerate towards the positive plate to which it is attracted. Now that we understand that our electron has moved through a distance d, which is equivalent to a voltage or a potential difference of 1 volt, we're able to move towards working out what an electron volt actually is. We know that in all of physics, work done is force times distance. And we also know that the size of an electric field, if it's uniform, is given by voltage between the plates divided by the distance between the plates. Lastly, we can also recall from our work on electric fields that the force on a charge Q is equal to the electric field strength times Q. So now we'll substitute in for F in work done is force times distance, and that gives us the work done is equal to electric field strength times the charge times the distance between the plates. And now we can substitute E equals V over D. And this will leave us with work done equals V divided by D times Q times D. Immediately we can see that we can cancel out the D's, and this leaves us with work done is equal to the charge multiplied by the voltage between the plates.
So we've seen that the energy gained by an electron as it accelerates through a voltage is just the charge times the voltage. And of course this energy is manifested as kinetic energy. So therefore we can say that the kinetic energy gained by a charge as it moves through an electric field is simply the charge times the potential difference. And of course, if we're talking about electrons, we can just replace that Q with our symbol E, which, as you know, is 1.6 times 10 to the minus 19 coulombs. And this then brings us to the final definition of the electron volt. 1 electron volt is simply the energy gained when you accelerate an electron through 1 volt. And since that is EV, we simply times 1 for the V by the charge of the electron, and the answer will be 1.6 times 10 to the minus 19 joules. So 1 electron volt is equivalent to 1.6 times 10 to the minus 19 joules. Now I often tell my students, if you don't get any of this, just remember the conversion factor. 1 electron volt is 1.6 times 10 to the minus 19 joules. This formula will obviously apply in many different situations. So for example, how much energy would an electron gain if it was accelerated through, let's say, 10 million volts? And what about if we were to accelerate an alpha particle through, say, 50 volts?